Good evening. It is awesome to actually welcome you this evening to our final year project evening. I'm Johan Hubert from the Department of Industrial and Systems Engineering, and it is my privilege to welcome you and celebrate our final year group. Can they see my slides? Am I unmuted? Well, of course I am. After 18 months, we should be kind of comfortable and becoming comfortable with talking into the oblivion into a camera and hoping somebody else is on the other side. And mind you, I think your mom told you to have limited screen time as well. But thank you for joining us and making some time available to celebrate our final year group with us this evening. I have a message for the students. Exactly 1 month ago, on the 25th of October, I took this picture. It was a gorgeous, rainy day on campus. The jacaranda's in full bloom, and I was on my way up to get a Chelsea bun, and I just had to take this picture. The problem is the only thing that is missing in this picture is you. We really would love to have you back on campus. Thank you for joining us virtually, but a message to our students: stay safe, sanitize, vaccinate, and we can open our doors soon to have you back on this beautiful campus again. But ladies and gentlemen, it is now my privilege, and I would like you to help me unmask the final year group, the class of 2021. These gorgeous students of ours are celebrating the end and kind of the capstone of their final year projects. And I would like to make sure that you have a glass of sparkling water or wine or a single malt or a cold brew coffee or a hot one or whatever your poison of choice is, and raise a glass to the class of 2021. If you are a parent or a grandparent of one of these gorgeous kids, I want you to give somebody a high five and say, well done, we've done it. And we would like to celebrate you this evening as well. If you are a financial sponsor of one of these students, thank you so much for helping them realize their dreams in pursuing a career in industrial engineering. If you are an emotional, a psychological, or spiritual support as part of their support network, we want to celebrate you as well. Thank you for your resilience and your patience in supporting them in this journey. For this one evening, we will pardon them and kind of forgive them for all the sorry, I can't project, sorry, can't engineering test week, sorry, I can't, sorry, can't attend. For all of those times that you had to absorb that, thank you so much. Tonight we celebrate them, but an evening like tonight is not possible without our sponsors and our industry friends. And here specifically, I would like to thank Adcorp, Bidvest, Pragma, Quincy, F&B, and DSV. Thank you so much. Many of you are longtime friends and collaborators with the department. Thank you so much for helping us make an evening like tonight and every year possible. Thank you for your support. If you're one of the companies that actually provided a final year project or a topic of some sort to any one of our final year students, thank you so much. You will see tonight the diversity, and it is because of companies like yourselves that this is actually possible. Thank you so much for the opportunity for entertaining the students in some sense, but also to support them in achieving and this learning opportunity that is their final year project. Now, this group of students tonight, and actually throughout the entire year, will be competing in one of three prize categories. We have, firstly, the best project report. Every student is required to write a neat and professional document in which they set out the scope of their project, in which they stand on the shoulders of giants by doing a thorough literature review, the design of whatever the artifact is that they're going to pursue, implementing the results, doing the inference and analyzing the results, and that is then written up into a document. This is assessed by an internal and external examiner, and a shortlist of the top candidates are then made available to our friend and former colleague here in the department, Dr. Peter Conradi. Peter, thank you again for availing yourself to go through this top shortlist of best project reports, and we will communicate the results to you later this evening. The best posters, some of which you've seen during the introductory video, are shortlisted and then evaluated by a panel and a committee within our department. And then tonight specifically is about the best project presentations. And here I would like to thank and welcome our panel of adjudicators, David Crew-Brown, Wessel van Heerden, Freddie Chikala, Dr. John Wenzel, Stanley McMillan, and Dr. Karen Trudeau. Thank you all for making yourselves available, for your time and your experience. All of these members of the panel are also alumni of our department, so thank you so much. And for your input in helping make tonight a success. Now, ladies and gentlemen, sit back, relax, and get ready. I am going to get out of your face and allow my colleague, the newest member of our department, to introduce the shortlist to you. Cholofelo Malachi. Cholo, take it away.
Good evening, ladies and gentlemen, and once again, welcome to this year's final year presentation, where we will be able to have a sneak peek into what our final year students have been working on throughout the year. What a privilege. We would first like to acknowledge the participants who made it to the top 18 selection round, and they are Ekisha Andy, Viam Barnost, Kaylee Bench, Travis Broudson, Tana Brownlee, Dante Chiapparini, Simone De Brain, Marnie Devitt, Lisa Fourie, Mohammed Haq, Mohammed Jaffa, Sarah McInerney, Nandisa Ngumalo, Marilee Oorlof, Juliana Skeepers, Maxwell Schoeman, Caitlin Tellick, and Christine van der Merwe. Well done to all of you. This is a clear indication of all your hard work. So a selection panel from the department evaluated all the 18 participants and selected our top 6 finalists for this evening. And they are Tana Brownlee, Mohammed Jaffa, Ekisha Andy, Marilee Oorlof, Sarah McInerney, and Caitlin Tellick. Well done to our finalists. You should be very proud of yourself. This is a great achievement. We will have the presenters in the order as shown in the program. And I will introduce our first presenter for this evening. Our first presenter will be telling us about the optimization of a seller layout for a wine distribution company. Please put your hands together for Tana Brownlee.
Good evening, everyone. Let me start off by asking you this question. Who here has ever moved houses before? Well, for those of you who have forgotten or are unfamiliar with this concept, let me just tell you what transpires. Basically, you pack everything you own into neatly labeled boxes. Bedroom, bathroom, kitchen. And you assume that when you reach the other side, you will know exactly where everything fits. However, that is never the case. And unfortunately, when it comes time to cook your first meal, all these questions start to arise. Where's the pot? Where's the pan? Where's my favorite knife? And about 2/3 of the time spent actually cooking the meal is spent just looking for the appropriate utensils. Now, if this is the chaos that happens in your 2x3 meter kitchen, can you imagine in a 270 square meter warehouse with over 10,000 bottles of wine? But now, let's add a level of complexity to it. Imagine you are looking for a knife with a specific serial number. You have a general idea of where your knives are kept, so you go over to the knife drawer, you open the drawer, and suddenly you are confronted with 4 identical looking knives. The only way to tell which one you are looking for is by picking up the knife, reading the serial number, and hoping that it's the first one you pick. However, that is seldom the case. The same can be said about wine bottles that have exactly the same label, but merely the vintages change. How on earth are you meant to know which product to pick? So this begs the question, why on earth am I telling you about a disarrayed kitchen and some wine bottles? Well, let me first tell you a little bit about the company. Great Domains is a South African company specializing in the distribution of imported wines and champagnes. They also sell numerous wine-adjacent products, such as spittoons, coravins, Zalto glasses, and currently import from 116 domains across the globe, from countries including Germany, Lebanon, France, Portugal, Spain, and of course, some locally grown South African wines as well. However, the company faces numerous problems. So let's take a look at them. Number one, the company does not have the capacity to store all of their products in their warehouse, to the point that Zalto glasses are stored 4 houses down the road at one of the owner's places. This means every time someone orders these glasses, the picker has to leave the site, walk to the owner's location, retrieve the glasses, and then come back, leading to an enormous amount of time wasted. Also, another problem the company faces is the fact that the logistics team is located in an office just off the main cellar. The logistics team is responsible for ensuring that each order is correct and client specifications have been met. Now, walking back and forth between the office and the cellar might not seem like a lot for 1 or 2 orders, but when you're dealing with 50 to 60 plus orders a day, it turns out to be quite the workout. However, the biggest problem the company faces is the fact that there is no set picking or packing structure to their inventory. We just thought about the chaos that happens in your 2 by 3 meter kitchen. Now picture that warehouse again with 10,000 bottles of wine. So this begs the question, right? What can be done? Well, simply put, the problem can be broken down into 2 parts. 1, the physical warehouse layout, and 2, the inventory slotting method. So let's first take a look at the physical layout. Systematic layout planning is seen as the most common and practical method in order to determine a physical layout. It has been tried and tested across numerous industries and has an easy 10-step methodology to follow. So this methodology was followed. Activity relationship diagrams were drawn, relationship diagrams, space requirements were gathered, space requirement diagrams were drawn, and of course limitations and constraints, and the previous design was considered. Eventually, 3 designs were drawn up. These designs were compared under a spectrum of factors such as lighting, warehouse flow, future expansion, and one design reigned supreme. The new warehouse layout allows for approximately 3,100 more bottles to be located within the cellar. Not only that, but the hanging shelving that is now located on the outskirts of the warehouse allow for all Zalto glasses to be moved into the cellar. The dispatch area has nearly doubled in size, and the logistics team has a beautiful new office to be located within the dispatch area. This ensuring them greater control over those customer specifications and ensuring that they get less of a workout. Not only that, but a beautiful U-shaped flow can be seen throughout the warehouse, with products arriving at one end, being distributed throughout the warehouse, and simply dispatched next door. Okay, fantastic. We have a great new physical layout. However, where does all the inventory go? Well, 2 inventory slotting methods were identified as appropriate, namely ABC analysis and COI analysis. ABC analysis distinguishes stock into classes. It utilizes the Pareto principle, of which I'm sure we're all familiar, that 80% of warehouse movement and sales comprise of roughly 20% of data. It does not merely look at the volume and quantity of stock, but rather its economic contribution to the company. COI analysis simply says, The more product is picked, put it closer to dispatch. So now, both seem like viable solutions. How does the company choose which is an appropriate method? Well, simply put, the company cannot afford to implement one strategy for 3 months and then another strategy for the next 3 months in order to gather the data required to make this decision. Fortunately, we live in a technologically driven era where tools such as simulation compress those 3 months into a matter of minutes. Any logic was identified as an appropriate simulation tool. Products were split between Coravins and Zalto glasses and wines and champagnes. Sales data from the previous year was fed into the simulation. Basically what happened is, if the sales order said fetch product X, the worker would move to the location of product X, pick the product, and then simply return to dispatch. Time and distance would increase accordingly. The product locations were determined via the ABC and COI analysis. So let's take a look at the results. As can be seen, COI analysis proved far superior in both total distance taken and total time taken. But now, is it a viable solution? Well, due to the simplistic nature of COI analysis, it requires very little technical skills in order to implement. And currently, the company has no set picking and packing structure. So what have they got to lose? Fantastic. We now have a brilliant new physical warehouse layout and a great new inventory slotting method. These layouts were implemented on site, and the space was completely transformed. The new layout takes a place that was cluttered and cramped and transforms it into something that's functional and operational. It takes a place that was at maximum capacity and a little bit messy and transforms it into something that is spacious and organized. The Virgin Active down the road has seen an increase in membership numbers due to the fact that no one is getting their step count in anymore. I hope that by listening to this presentation and recognizing the importance of a good layout, you all feel a little bit inspired to go home and redo your kitchens. Thank you so much for your time.
Yes, Tana, we can all relate to the chaos that comes with moving. Well done on introducing that new layout and the inventory management system. Our next presenter will be telling us about streamlining production planning and inventory management processes at Habit Oil. Please put your hands together for Mohammed Jaffa.
Good evening, ladies and gentlemen. I would like to guide you through a process of streamlining the production and inventory planning processes at Habit Oil. Habit Oil is a lubricant manufacturing company situated in industrial Johannesburg. They specialize in the production of mineral and synthetic lubricants that service predominantly the automotive and industrial markets. Habit manufactures all of their products in 3 ranges, specifically their mineral high-performance range, their semi-synthetic superior performance range, and their fully synthetic ultra-performance range. The core separator between each of these ranges is the type of base oil used to manufacture the product. Well, what is a base oil? Base oils are the heart of a lubricant blend and are classified into 5 groups. Groups 1 to 3 are derived from crude oil and are used in the synthesis of mineral base oils, whereas groups 4 and 5 are used in the production of fully synthetic lubricants. Synthetic oil offers improved application performance over mineral base oils. However, this comes at an increased cost gap. To make a lubricant, base oils and chemical additives are blended together in varying proportions. Roughly 60 to 90% of a finished lubricant is made up of a base oil, and 10 to 40% is made up of a chemical additive. After the blending process has been completed, it is being transferred to bulk storage, where it is then decanted and packaged into a number of different pack sizes. A good motor oil will minimize engine wear increased performance, and increased fuel efficiency. With this in mind, supply chain specialist Tony Weil quotes that inventory is the fluid that lubricates the wheel of the supply chain. By re-examining the process again, with respect to Habit's inventory, we can see that there are two kinds of inventory: raw materials, quantified in kilograms, and finished products, quantified in terms of liters. Well then, what problems does Habit Oil face with respect to its inventory? Products are classified as either fast-moving or slow-moving based on the historic sales volume and the course over 3 months. Those that have high sales volumes are classified as make-to-stock. This process, however, does not consider fluctuations in demand, and products are continually relegated between these two categories. As a result, inventory levels tend to either be too high or too low with respect to its demand. And this leads to the third problem, which is a lack of sufficient demand forecasting. Currently, Habit only uses a 3-month moving average system to forecast future sales. With demand uncertainty, production planning is compromised. Production quantities continually vary, resulting in non-optimal production costs. This brings us to the aims of this project, which are to firstly forecast demand accurately, thereafter create a production planning model, and lastly reach a solution that minimizes production and inventory costs. To do so, the following approach was followed. Firstly, classifying inventory according to its importance and determining whether they should be determined as make-to-stock or make-to-order. Thereafter, forecasting techniques shall be applied to these products to determine their future outcomes. And lastly, the use of a master production schedule shall be used for production planning, and then inventory requirements can therefore be consolidated. The ABC analysis, rooted in Pareto's principle, separates the trivial many from the vital few. Habit Oil currently has over 100 different SKUs that they manufacture. Thus, determining those products that have the greatest impact on production cost and profitability were analyzed. Through an ABC analysis, 13 products in total were identified that simultaneously contribute to 70% of the total production costs. These 13 items are thus selected as the basis of this model, where demand forecasting approaches shall then be applied upon. To create a demand forecast, 16 months worth of historical sales data was used to forecast demand using time series forecasting approaches. 3 approaches were used to forecast demand: a moving average of 3 months, exponential smoothing, and regression with trend. Each approach was used to forecast demand. The approach that yielded the lowest mean absolute deviation for each product was selected as its forecasting method. The mean absolute deviation is computed as the actual sales minus the forecasted demand. The associated table highlights each of the 13 products and the preferred method to forecast its demand. And this moves us on to the topic of production planning. The concept of lot sizing was used to determine an optimal production quantity for a given product. The economic production quantity model provides an optimal cost reduction solution that was applied to every single product. Inputs to this model include annual forecasted demand, production costs, and a production rate equal to 4,000 liters a day. Thereafter, the use of a master production schedule that takes into account the planned orders and forecasted demand is used to plan production runs. This allows fluctuations to be addressed where the lot size within the master production schedule is equal to the economic production quantity. To address the fact that finished lubricants are quantified in terms of volume and raw materials are quantified in terms of kilograms, an improved bill of material that incorporates product densities bridges the gap between volume and mass requirements. This is beneficial as it allows Habit Oil to better plan the procurement of raw materials, such as through the use of economic order quantity modeling. Demand forecasting, as mentioned earlier, is an integral component to the solution. It is thus important to ensure that forecasting results are sufficient to predict customer demand. Forecasted demand was compared with actual demand for September 2021. The associated graph highlights the accuracy of the forecasting system. In order to ensure that unbiased forecasts are not present, a tracking signal computation was used. The analysis highlighted that all forecasting methods selected are in control and forecast bias is currently not present. The critical aspect of this model solution is the component of cost reduction. The total actual production volumes for the month of September were compared to the outputs of the design model. The difference in production costs between the two models were compared, and it is clear that there is significant production cost savings with the developed solution model. In total, for the 13 products, the model would have saved the company 19% with respect to its production cost for the month of September 2021. Well, what can we say are the key takeaways of this project? Firstly, through this model, customer demand can be satisfied. We can reach an optimal reduction in carried inventory levels. And lastly, we can lower the overall production costs for the company, highlighting the overall success of this project. And with that, I'd like to say thank you.
Well done, Mohammed, on the excellent execution of production and inventory planning strategies. I'm sure you've saved the company some serious money. Our next presenter will be telling us about improving the downtime caused by logistics using acceptance sampling. Please put your hands together for Akisha and Dee.
Is it the aroma of malt and hints of honey? Or is it the medium and bitter body? Or perhaps, is it the refreshing feeling which makes it more appealing? Well, whichever it is no doubt that a good quality beer will put your mood in a cheer. Good day to all viewing my presentation. Today, I'll be speaking about improving the downtime caused by logistics with acceptance sampling. South African Breweries, commonly known as SAB, is a leading distributor of alcoholic beverages since its establishment in 1895. SAB is a proud part of the AB InBev family, where it is known as the largest brewer internationally to be able to produce over 400 alcoholic beverages. With 7 breweries and 42 depots nationally, the brand portfolio includes 5 of the 6 most consumed beer brands in South Africa, namely Carling Black Label, Hansa Pilsner, Castle Lager, Castle Light, and Castle Milk Stout. Some of these national favorites, which you might recognize, are produced at one of the 9 production lines located north of Gauteng, in Roslyn. Roslyn Brewery operates for 24 hours a day for 7 days a week to meet the demands of the monthly beer volume of 80,000 hectolitres per month. This increasing volume is maintained by the SAB supply chain, which can be described as a closed-loop supply chain, encompassing of both the forward and reverse logistics. The forward logistics is the movement of the finished goods from the brewery to the end customer, and the reverse logistics is the movement of the empty returnable bottles from the end customer to the brewery, where the bottles can either be reused or disposed. The problem I identified at Roslyn is the quality of returnable bottles which are entering the reverse supply chain that have a direct impact on the production lines. The stoppage of the production line filler due to errors caused by logistics activities is represented by the downtime caused by logistics, the DCBL, which is a key performance indicator. In the first 4 months of 2021, the DCBL exceeded all monthly target values. So, as a beer lover, how does this impact you? Well, the negative impact of the stoppage of the production line results in lower productivity and therefore a loss of investment, which means a greater chance of stockouts when you want your favorite beer. So, to avoid stockouts, I went about analyzing the DCBL KPI in terms of one of its main contributors, the returnable bottles. The primary objective of this project was to analyze the returnables bottles process in terms of the survey of missing, broken, foreign, and unwashable MBFU, which is completed on 1 pallet per empties brand type. The secondary objective of this project was to identify root causes and to present a feasible solution to reduce the non-conforming bottles from entering the reverse supply chain. To achieve these objectives, my approaches for the project included DAMAC, which I used to guide the project from beginning to recommendations, statistical process control, which I used to analyze the current MBFU survey, measurement system analysis, which I used to analyze the current MBFU survey, acceptance sampling, which I used to develop a plan to control the non-conforming bottles, and lastly, analytical hierarchy process, which I used to evaluate between the acceptance sampling plans based on priorities and criteria. Using the IE techniques, my analysis included the collection of the data from the MBFU survey, which I imported, sorted, and simplified using RStudio. Using this attribute data collected, I used the binomial distribution, where the returnable bottles can either be considered as conforming or non-conforming to quality attributes. Based on this classification, I formed the NP control charts of the depot and customer data and applied the Western Electric sensitizing rules to find that both processes are out of control. In addition, I analyzed the measurement system of the MBFU survey workers in terms of reproducibility, stability, and bias to find that the average time to survey one pallet was 15 minutes. Now, given that the measurement system is a human who is responsible for the finding of the non-conforming bottles, the measurement system is subject to human error. Using the results from my analysis, I found the opportunities for improvement through a 5-why analysis, which found that the root cause of being no acceptance sampling in place. So, why acceptance sampling, you may ask? Well, implementing acceptance sampling will aid in the tracking of the non-conforming bottles and promoting the decision-making of the frontline to either accept or reject the truckload. So in order to formulate these plans, I determined the lot formation, which I based on the average quantity return from the depots and customers, the acceptable quality levels, which I based on the major and minor defects from the AQL tables, and the producer risk point, which I based on the alpha and beta values on the OC curve. Using these criteria, I formed the 3 plans using various consumer risk points, CRP, quality, and probability of acceptance, which are analyzed in RStudio to verify that all plans meet the desired risk. The selection of the acceptance sampling plans amongst alternatives are used based on the OC curve, feasibility analysis, and analytical hierarchy process. To formulate the OC curve, I used the various consumer risk points, CRP, quality, and probability of acceptance to find that the shape of the 3 curves follow the typical OC curve, with Plan 1 showing the closest similarity to the ideal OC curve. For the feasibility analysis, I developed a cost model which included the acceptance, rejection, and inspection costs. The acceptance costs I based on the probability of accepting the non-conforming bottles with the intention to cullet it. The rejection costs I based on the probability of rejecting the truckload. And the inspection costs I based on the cost to survey the truckload. Using this model, I formulated the total cost of the 3 plans, which showed that Plan 3 had the lowest cost of 408 Rand per truckload. Lastly, I formulated the AHP model, with the criteria being cost, quality, and usability, and the alternatives being the 3 plans. Using the Super Decision software, I analyzed the AHP model to find that Plan 1 was the most feasible solution, which I verified using a sensitivity analysis. So your next question might be, why acceptance sampling over the current process? Well, the current process costs comprise of the MBFU write-offs and the associated labor, which results in an increasing trend, indicating the negative impact on the current process. In addition, I analyzed the current effectiveness of this process in terms of the adjusted amount to be paid by depots, which shows a decreasing trend. However, when comparing this to the implementation of Acceptance Sampling Plan 1, the cost will comprise of the cost to complete the plan and the recharge received due to the increased accountability from the tracking. This would result in a cost saving in all 4 months, indicating that the solution will be beneficial to the company and should therefore be implemented. For my recommendations for the implementation, I suggest that the MBFU survey workers should be subject to an attribute gauge R&R study in terms of time and effectiveness. In addition, for the implementation of Acceptance Sampling Plan 1, I recommend that the Plan Do Check Act loop should be used. To aid this execution, I created the documentation of the standard operating procedure, which includes the short interval control graph to track the non-conforming bottles, and a process map to assist the workers when completing the survey. In conclusion, given the magnitude of the SAB operations, the reduction of the DCBL, even by a small percentage, seems minimal. However, the DCBL is an important KPI, and therefore aligning this to the vision of operational excellence will help achieve continuous improvement in this problem. Because at SAB, we are brand builders, where quality is what we deliver.
Well done, Akisha, on the proposed acceptance plans. I'm sure they will ensure that we all get our favorite beer while it's still cold. On that note, we will have a short interval to allow you to grab that cold one, or hot one for that matter, while we bring you some exclusive interviews with our finalists. Please stay tuned.
Good evening and welcome to the final year project evening. My name is Elizabeth and I'm an honours student and currently employed at the Department of Industrial and Systems Engineering. With me I have 3 of the 6 finalists. Congratulations you guys. I know you've been working really hard to get here. So maybe just start off by introducing yourselves and telling us why you studied industrial engineering. Yes, Tana, maybe you could start.
Perfect. Good evening, everyone. My name is Tana Brownlee. Well, basically, I chose to study industrial engineering because of an evening like this. I came to a projects evening when I was in grade 11 with my mom, and I was deciding between whether I should study accounting or industrial engineering. And what happened is I saw the 6 finalists and was completely blown away at their caliber. And from then on, there was no discussion in our house as to what I was studying. It was known.
And you, Mohammed?
I've always been interested in, the advancements in, for example, the 4th Industrial Revolution and where we are and where we're moving with technology. I've always been very technologically inclined. But I've always been a question asker. I've always wanted to know, ask things and find out the answers to things. And I feel like engineering bridges that gap with, technology and creative solutions towards problems. And that's why I decided to choose industrial engineering.
Oh, wow. And you, Keisha?
Oh, well, I don't think mine's as technical as Jaffa's, but I think I chose it because, my parents were really, they always told me to, hard work comes success. And my dad's an engineer and, he always was very technical and I like that, the technical part of it and being creative. And I think that's what this project helped me, it helped apply that, creative part of it. And I loved just the entire 4 years of my degree, and yeah.
Oh, wow. I don't think I can think of one good reason. I know when I needed to decide, I think a lady working at a farm, they plant edible flowers and miniature vegetables, and she completely just convinced me that industrial engineering is the best degree to study, so that's why I'm here. Thank you. So, Tana, what do you call a fat penguin on ice?
I'm not sure.
An icebreaker. Okay, now that we've gotten that out of the way, I want to ask Mohammed, how many pairs of shoes do you think an industrial engineer should own?
I'd say 4 and a good pair of sneakers.
How many do you own?
4 and a good pair of sneakers.
Oh, wow. I think I've got like 34 pairs of shoes. Okay. And so I'm going to ask Akisha, if you could describe industrial engineering to someone, so what it is or what you do with one word, what word would it be?
Oh, no. Optimization.
Wow, you Tana?
She stole mine.
Mohammed, do you have a different one?
I'd say basically, industrial engineer is basically a doctor for businesses,
Wow.
making their businesses more efficient and healthier.
That's a good way to think of it. So while we're on the one-word train, Tana, how would you describe your final year in one word?
Hectic.
And you, Mohammed?
I'd say it was a growing experience, collaborating with peers, working, having goals, and just learning a new ethic in work life.
That's a lot more than one word.
Oh, it's supposed to be one word. Okay,
Keisha,
one word difficult.
Okay, that's a good one. Anyone?
Exciting. Yeah.
Okay. I would just say yo. That's my response. But anyway, Mohammed, did you have like one song or motivational quote that you listened to, or used to remind you to work hard and that everything, it's not that difficult, not that hard? What was that song or quote or that one thing?
There's one thing I always listen to when I study. It's the Interstellar soundtrack. It just pumps me. So,
That's a good one.
That's
That's
my
a good
answer.
one. Dana, do you have a specific song that you listen to?
I always listen to Walking on Sunshine. It makes me feel a bit better.
I can imagine. Yeah, Keisha?
Oh, sure. I have so many songs, but I honestly think it's like, your Rather Be by Clean Bandit, because it's like there's no place I'd rather be, but yeah.
Oh, wow. Yeah, it depends on what mood I'm in. Anyways. Keisha, if I could, I want to know, what's the one thing that you regret not doing while you were still on campus?
Oh, I think spending more time on campus, because I think the past 2 years I've lost out on that experience, and I actually miss campus so much, weirdly. Apart from writing tests and everything, I think that's what I miss, is just being here and that atmosphere of everyone doing things, and being on the aula grass, and
Not being isolated, sitting at home,
Yeah.
trying to figure out everything on your own. I think that's the big part. So, Tana, what was your ultimate favorite memory of your entire academic career? So it can be class-related, res-related, social, whatever. Just your ultimate favorite memory.
My favorite memory of university. It's actually a res experience I had. We used to do like a huge production called Step It Up, where there'd be like 150 people on stage and you performed in front of like 1,500 people. And that exhilaration, standing there trying to remember your dance moves. I messed up all the dance moves, but it was still, I think that's definitely one of the highlights of mine.
Definitely. Mohammed, yours?
I'd say the most interesting or weirdest experience on campus I've had was late night study sessions with friends in engineering 3 and then getting locked inside the building until the next morning.
To the next morning. Did you find the number on your student card?
We decided to pull an all-nighter and then
Okay. Keisha, I hope yours doesn't involve an all-nighter.
No. I think for me, I honestly think it's after a test, that feeling, like, I think that's the best time. And I don't know.
Okay, that's fun. So you all know that game you usually play. It's on an Instagram story. It's this called This or That. So I'm gonna do that with you guys. You can answer at once or just everybody give your answer. But I'm gonna read two things and then you say which one you prefer or the first one that comes into your head. Okay, are you ready?
Yes.
Okay, start off easy. Coffee or tea?
Tea.
tea.
Oh wow. Okay, coffee. Star Wars or Lord of the Rings?
Lord of the Rings.
Yeah.
I haven't seen either.
Are
Sorry.
you an engineer?
Clearly not.
Okay, campus class or online learning?
Online.
Online.
Campus class.
I like you. Pineapple on pizza, yes or no?
No.
No.
Yes.
I'm with you. Working hard or hardly working?
Working
Working
hard.
Working hard.
Oh, wow. That's why you're all standing here today. Textbook versus ebook.
E-book.
Interesting. Okay, and another one with regards to the online learning. Do you join the live class or watch the recording of it afterwards?
Recording.
Makes sense. And the last one, procrastination or procrastination?
Procrastination.
Okay, great, you guys. So the last thing that I want to ask you is if you have any piece of advice that you would give to a third-year student or a younger student going into their final year, what would it be? So just anything that you this year that taught you that you learned this year. Tana, maybe you could start.
I think maybe to just keep going. I think, sometimes it can get a little bit overwhelming and, you're not really sure. I don't know, I had lots of moments of doubts of, am I really studying the right thing? Am I going to make it? But, I think the biggest thing is just to keep going and just take it like one day at a time. Don't look too much at the bigger picture because that gets quite scary.
I'd say definitely find yourself a good group of friends, you know, that y'all can push and work through together. The difficult moments, it's difficult for you all, but you'll know you're all in it together. So definitely make good friends and yeah, enjoy the journey, you know. It's an interesting one.
I would say don't give up. You know, no matter what life throws at you in your degree, never give up on that. And yeah, I faced so many obstacles in these 4 years, and yeah, it's still unbelievable that I'm here now, and I'm still shocked. But yeah.
Wow. Once again, congratulations, you guys. And from the department side, I just want to present you with a small gift for your hard work and making sure that this night is a success. Congratulations, you guys.
Thank you so much. Thank you.
Hello, I'm now joined by the second group of students. Congratulations, you all, for being here. Maybe you could start off by introducing yourself and just telling us why you decided to study industrial engineering. Marley, maybe you could start?
Okay. Hi, my name is Marilee Wilhoff, and I think the story behind why each of us actually started studying is probably longer than can be captured here. But in essence, I actually have a background in social work. That's my primary passion. And working in the welfare organizations, I saw that in this country, so many of our systems are broken. And I realized that there's maybe a unique solution. So I decided to actually chase my aptitude and study industrial engineering to see if I can make a difference.
Wow. Sarah?
Hi, I'm Sarah. Yeah, like Marley said, there's a long drawn-out story as to why I chose industrial engineering, but it all levels down to the diversity of subjects and the wide range of opportunities you have afterwards and all the different avenues you can make difference in with the degree. So, yes.
You, Caitlin?
I chose to study industrial engineering because growing up I had a wide variety of passions and interests, and finding this degree that covered everything from like thermodynamics to business law and all the exciting optimization in between was like super exciting. So yeah.
Okay, cool. So while you're speaking, what do you call a fat polar bear on ice?
I don't know.
An icebreaker.
Nice.
Anyways, Sarah, if industrial engineering could be a flavor of ice cream, what flavor would it be and why?
I'd have to say like Neapolitan, you know, or like a flavor of ice cream where there's so many distinct different flavors. Yeah.
Well, that's a good. All the answers that I got previously was vanilla, and that's a bit boring. I'll just add some sprinkles or something. So, Marley, maybe you could start us off with this one. Tell me you're an industrial engineer without telling me you're an industrial engineer.
Ooh, I can make anything better.
Oh, wow, okay. Sarah?
Oh.
What did you say?
No.
Okay.
Yeah, same energy as Marilee. Like, there's probably a better way to do that.
Yeah.
Yeah, definitely. I would say a professional organizer. That's what I think I do on a daily basis. But anyways, so Sarah, what food or snack got you through your final year?
Maggie's 2-minute noodles all the way from day one.
Are you in res or?
I used to be and boarding, so I have experience.
That's where it comes from. I think I ate a lot of Cinnabons and Sparkles. Yeah, that was my go-to. I don't know if you want to add something, Caitlin?
I just ate a lot of ice cream. It helped emotionally as well.
That helps. Ice cream always helps. Miley, did you have a preferred snack?
Sure, I actually don't think so. I think I was actually on a farm for my final year, so shops weren't very close by. So basically whatever was closest.
Okay, makes sense. Okay, so Caitlin, I want to ask you, what is the most useless thing that you spent money on or bought during your academic career?
I went into the calculus modules with my calculator, and I was like, this is absolutely an essential. And then on the first day, they were like, no, none of that. No calculators. Definitely waste of money. Don't bother getting a calculator.
Yeah, but you might need one for some of the other subjects.
Later,
Yeah,
much later, yeah.
Yes. Is there anything that you guys want to add? Marley?
Without implicating any modules whose textbooks may or may not have been great, I'm gonna refer no answer.
Okay. Sarah, was there one thing specific that...
I think in first year I bought a lot of stationery and lots of multicolored pens, thinking I could make notes like high school. You don't have the time.
No.
You just get a black pen.
Get a tablet with a pen.
Yes.
That works the best. That's out of my personal experience. So Marley, if you were stranded on an island with one of the department's lecturers, who would it be and why?
That is probably the easiest question that you could ask me. Ilse Doyer.
Really?
Yes. I absolutely love her energy, but also the way that she approaches everything she does. I mean, thinking back of the many times that I'd ask her a simple question and she'd actually phone me, and it would be like an hour conversation, really trying to make an effort and build into the lives of her students. So yeah, I think above and beyond her actual skills, she's a good conversationalist as well.
Okay. Sarah, is there someone else that you would like to be stranded on an island with?
I think I would say Dr. Bean. She just always has such a calm and motherly aura around her, and she does logistics, so I think she could find us a way off the island maybe.
That's probably. Caitlin?
I think luckily this is an industrial engineering department, so I'd probably be in safe hands, whoever I picked in terms of getting things together.
No, most definitely. I'll try and make a plan somewhere. So we're going to play a game. I don't know if you guys are familiar with Never Have I Ever. So it's going to be a bit different, but I'm going to make a statement, and then if you haven't done it before, raise your hand. So if you have done it, don't raise your hand. Okay. So the first one is, never have I ever skipped a Friday lecture. Oh, wow, okay. Never have I ever fallen asleep in class. Yeah, I've done that. Never have I ever missed a class test because I went to donate blood.
Is it up if I have never?
Yeah.
I
Oh, you
haven't
do.
done
Sorry.
Okay, sorry,
Yeah.
that was
Sorry.
pretty specific, but
Process,
I did
yeah.
that once. Oops. Never have I ever been late for class after running down to Alawa to buy a quick coffee.
Oh, wait.
And never have I ever muted an online class while doing something else. Oh, wow, okay. And the last one, never have I ever not gone to class just because it's raining. Oh, wow. No, it's dangerous. You can't go to class when it rains.
I agree.
Anyway, so I want to conclude by asking each of you if you have a piece of advice from your final year for a younger student or a third year who's going into final year. Maybe you could share that with them. I don't know if Marley wants to start.
I think the most important thing really is to find community and to realize that this really is supposed to prepare you for the real world out there. And you can't operate in isolation. The number of times that our final year group actually carried each other throughout this year is remarkable. I mean, from giving advice to interviews and CVs and just giving some practical pointers in specific modules, it really makes a difference. So get to know people, get plugged in, and don't try and do it alone. Even if it's your degree, you're going to need some help.
Definitely. Sarah?
So for me, what always gets me through difficult tests and those long assignments, one on top of the other, is to just remember that someone else has done it before you. It is possible, no matter how impossible it seems. Just a little time and effort, and you can get through it the same as everyone else.
No, most definitely. Caitlin?
I'd say do your best to enjoy it. You're not going to enjoy all of it, but try your best to enjoy some of it.
No, that's perfect. So congratulations, you guys, once again. And from the department side, we just want to give you guys a small gift as a token of appreciation for all your hard work and for being here. And yes, I know circumstances have been difficult, especially for you guys. You've been online for the last 2 years, and I know how that feels. But yes, congratulations, and we just have something small for you. Thank you very much. Thank you, Sarah.
Thank you.
Thank you, Marley.
Thank you very much.
Welcome back to our program. Now we will have the last three presenters who will present in the order as shown in the program. The next presenter will be telling us about maximizing milk production at the Hillside Farm Trust Dairy Farm. for the next 10 years. Please put your hands together for Marilee Ulof.
I am not in the slightest degree impressed by your bigness or your material resources as such. Size is not grandeur. Territory does not make a nation. The great issue about which hangs a true sublimity and the terror of overhanging fate is, what are you going to do with all these things? This quote by Thomas Hewley was quintessential to the final year project I completed at the Hillside Farm Trust Dairy Farm, which focused on increased and sustainable milk production. This presentation will provide an overview of how Hillside Farm Trust can remain competitive in South Africa's dairy industry. The global dairy industry contains about 118 million dairy farms, with 17% of production animals found on larger commercial farms. 96% of those animals are either cows or buffaloes. Liquid cow's milk makes up 54% of the market share. The average global herd size is 500 cows, with the largest herd sizes found in Saudi Arabia, New Zealand, and South Africa. South Africa's dairy industry contributes 0.4% to the global dairy market, and there are currently about 1,050 milk producers operating in South Africa, making this a highly competitive market. The number of milk producers have dropped from 1,834 in 2015 to only 1,053 in 2021, translating to a 43% decrease. At the same time, milk production has increased with about 700,000 tons over the last 10 years. This is expressed as a 26% rise in milk production. Taking both these trends into account, we see that the milk production per producer has increased with about 2,000 tons over the last 10 years. This is a 220% rise in milk production per producer. Over the last 5 years, we've seen an increase in the consumption of dairy products, as is reflected in the upward linear trend in dairy production and demand. At the same time, we've also seen a trend towards larger herd sizes and fewer dairy farms, calling for the exploitation of economies of scale. This has led to widespread adoption of Industry 4.0 and precision dairy farming practices. Hillside Farm Trust is one of the 1,053 milk producers currently operating in South Africa and have been operating in the dairy industry for the last 80 years. The farm is situated in Bergville, KwaZulu-Natal, which is ranked as one of the top 3 milk production provinces in South Africa. The farm is classified as a medium producer of liquid cow's milk, with a peak milking herd of 370 and an average milking herd size of 330. Currently, Hillside Farm Trust's daily average is 17.4 litres per cow, which is below the national daily average of 20.1. As such, Hillside Farm Trust's current milk production is not sufficient to remain competitive in South Africa's dairy industry. This project aimed to maximize Hillside Farm Trust's milk production over the next 10 years. An in-depth literature review and company analysis guided solution development, wherein appropriate industrial engineering tools and techniques were used to create a roadmap that will guide Hillside Farm Trust to optimally scale their dairy farm and ultimately maximize their milk production. The literature review provided critical insights into the key milk production factors to consider when maximizing milk production, and revealed how automated control systems and forecasting can be used to achieve this goal. The literature review also guided the use of appropriate industrial engineering tools and techniques in both analysis and solution development. Moving towards Hillside Farm Trust company analysis, we first take a look at their current milk production process. As you can see, this is a highly complex process with various inputs, sub-processes, and outputs. So let's take a moment and break this down to simpler components. There are 4 key elements in the milk production process: liquid milk as Hillside Farm Trust's main product and source of income, and the 3 core processes that contribute towards production. These processes are feeding, dairy herd management, and the physical milking process. Each of these core processes have their own unique inputs, processes, and outputs that make them complex in and of its own. Hillside Farm Trust has incorporated animal monitoring technologies and farm manager software to help with managing this complex process. At this stage, their milking process takes place at a herringbone dairy facility design, using automatic milking machines and automated feeding systems. As the dairy cows enter the milking parlor, individual activity tags are picked up by sensors that register each cow's position in the production line, allowing the farm manager software to capture milk production data relating to each cow. Automatic milking machines are used to capture this data and to automate the milking process. Automated feeding systems distribute feeding rations to each cow's unique feeding needs. After milking, cows are sorted for artificial insemination and treatment using the activity tags to automate production flow. Hillside Farm Trust's current milking parlour limits their herd to a maximum of 500 cows, with an optimal milking herd size of 400. Taking into consideration increasing demand and a highly competitive market, the SWOT analysis revealed that Hillside Farm Trust's biggest weakness is their limited capacity for growth, whereas their biggest strength is their incorporation of Industry 4.0 and precision dairy farming. The SWOT analysis informed TOES matrices that were used to develop 4 maximization strategies, focused on growth, internal and external development, and survival. These 4 strategies informed the development of 10 possible projects to implement at Hillside Farm Trust. The growth strategies include the Milk Parlour Project, the TMR Project, and the Forecasting Project, focusing on building and constructing a new milking parlour and feeding sheds that will ultimately increase the farm's milk production and herd carrying capacities, with the Forecasting Project pinpointing the exact moments of execution. The Cash Cow Project and Project Productivity seek to exploit the farm's resources and maximize their throughput, with the Upskilled Labour Project preparing their staff for the implementation of these projects. Project Automation seeks to further exploit opportunities in technological development. The Market Research Project seeks to establish the farm's current position in the dairy market and ensures that they will regain their competitive advantage. The Power Project and Project Kaizen seeks to mitigate risks. The Power Project and Project Kaizen 24/7/365 seeks to mitigate risks. The Power Project specifically targets the risk of an unreliable power source, whereas Project Kaizen 24/7/365 seeks to place the farm in an optimal position to ensure that they can handle the changes in the dairy market. These 10 projects were filtered using Six Sigma project selection. An impact effort matrix using specific impact and effort criteria was used to plot these projects on an impact effort matrix. Projects that scored low in terms of impact were eliminated, and 7 projects were selected for implementation. These projects are Project Productivity, Project Kaizen 24/7/365, the Forecasting Project, the Cash Cow Project, Project TMR, Project Automation, and the Milk Parlour Project. Each of these projects targets specific milk production factors, but when executed in isolation, will not provide a holistic solution. As such, project execution will be driven by automated control systems and forecasting. Using the Kaizen, Kaikaku, and Kakushin improvement philosophies, a project execution timeline was developed using this project relation diagram, informing the interrelations between the 7 selected projects. This project timeline acts as a roadmap to guide Hillside Farm Trust in optimally scaling their dairy farm. The Forecasting Project is placed at the very beginning, as this informs when each project needs to be executed. The Cash Cow Project, on the other hand, seeks to exploit Hillside Farm Trust's current resources to set them up for the costly projects that are to follow. The Milk Parlour Project is the most disruptive project, as it changes the entire milk production process. This will be followed by a time of project automation, wherein the already incorporated Industry 4.0 and precision dairy farming practices needs to be relocated to the new milking parlour facility. After this, the farm is set up for increased herd size capacity. This triggers Project TMR, which sets up feeding sheds that ultimately increases the farm's herd carrying capacity. Throughout this project execution timeline, Project Kaizen 24/7/365 and Project Productivity act as a baseline that magnifies the impact of all the other projects, and they have to be executed throughout. It is important to remember that progress cannot be generated when we are satisfied with existing solutions. The presented solution is dynamic, and without continual monitoring, it will not be successful. The dairy industry changes daily, and they need to adapt these project executions according to those changes. Thank you for your time.
Well done, Marilee, on the excellent input that you provided in order for the company to prioritize projects to ensure optimal milk production. Our next presenter will be telling us about a dynamic class-based storage assignment policy to increase warehouse throughput. Please help me welcome Sarah McInerney.
Searching. There is nothing more frustrating than searching. Searching for your keys when you are late for work is bad enough. Now imagine if you are searching in an overpacked, disorganized, 7,000 square meter warehouse. This is the challenge faced by order pickers at AgriCorp SA. Good evening. I will be presenting the development of a storage assignment algorithm to increase warehouse throughput. AgriCorp SA is a fictitious name for a real, large-scale wholesaler and distributor of agricultural products in southern Africa. They own a warehouse in Centurion. This warehouse stores over 14,000 different product lines with 190,000 products flowing through the warehouse every day. The warehouse is facing a storage location assignment problem. This stems from the random storage assignment policy, according to which incoming inventory is placed into any empty bin. As a result, order pickers travel long distances in search of products. Fewer orders are picked per day and customers wait longer to receive their products. Quick order fulfillment is a primary component of customer satisfaction. These factors contribute to higher order picking times and reduce the warehouse's throughput. The aim of this project is to solve AgriCorp SA's storage problem by developing a dynamic algorithm, the objective of which is to establish the optimal placement of each product in the warehouse, thereby improving the order picking process, increasing warehouse throughput, and enhancing operational efficiency. To assess the nature and severity of the problems faced, the project's environment was investigated using data analysis and lean management principles to identify wastes. The first and most pressing issue identified is the order picking rate. AgriCorp SA set a target of 5,500 transactions to be picked per day. Currently, they are achieving a picking rate of 4,900. This is 600 transactions below the target value. Forklifts are required to retrieve products stored on high-level shelves. Per day, the company aimed to pick a maximum of 15% of products from high-level shelves. Currently, this figure stands at 39%, causing delays in the process. Smaller issues were also identified. The warehouse stores over 4,500 obsolete products in low-level bins. In addition, products are being stored in bins that are larger than required, leading to half-empty bins being overlooked in the packing process. Consequently, the warehouse is operating 62% above its capacity, with excess stock being stored in pathways leading to congestion. All of these issues provide the opportunity for process improvement, and thus an improved storage process has been developed considering the following requirements: to increase the number of orders picked per day, to decrease the order picking time, to minimize the number of high-level picks, to remove obsolete stock, move products to correctly sized bins, and to reduce the warehouse overcapacity. As a starting point, literature on inventory management storage policies was studied. This study revealed that the most popular and effective storage policy is the class-based storage policy. This policy divides products into classes according to predetermined class criterion. Specific classes are then allocated to dedicated areas of the warehouse, and within these areas, products are placed randomly into the closest open storage bin. 3 class criteria have been identified: ABC classification, family grouping, and actual sales combinations. ABC classification splits products into 3 classes based on a specific factor. In this case, the frequency at which products are picked. The A class consists of the products that account for 80% of the product picks, the B class 15%, and the C class the final 5%. The A class products are then allocated to preferred storage locations. ABC classification combined with family grouping ensures that like products are stored together. Products are grouped according to specific characteristics or their department. This helps pickers when locating products. Unfortunately, products can belong to multiple families, leading to confusion. The most frequently picked product family is stored closest to the shipping area. Finally, ABC classification combined with actual sales combinations is a variation of family grouping, where products that are commonly sold together are grouped according to their product affinity. Product affinity is a measure of the likelihood that a customer will purchase a product, given that they have purchased a specific product already. The most frequently picked product family is then again stored closest to the shipping area. 3 models were developed based on the alternatives presented. Data on the products, as well as the previous year's picking transactions and sales orders, were used to develop these models. Each model sorts the products into classes and then ranks them in order of preference for packing. The highest ranked product is placed in the most optimally placed bin. Once all the products have been ranked, so are the bins. This is done using inventory management classes. Now the warehouse is divided into zones, each containing bins of different sizes. Each zone can house products with a specific characteristic, such as flammable or high-value products. The IM class defines both the zone and the general location, that is high or low shelves. The desirability of a bin's location depends on its proximity to the ground and its proximity to the shipping area, and thus all the bins and their corresponding IM class are ranked according to their location. A packing algorithm was then developed in R using the product and bin rankings. The algorithm ran 3 times, each iteration using an alternative model as input. Every product class was assigned to various IM classes. Within the IM class, the highest ranked product was assigned to the highest ranked bin, the second highest ranked product to the second highest ranked bin, and this process was repeated until all the bins in the IM class were packed. The algorithm then moves to the next highest ranked IM class and repeats the process all over again, stopping once all the bins have been packed or once all the products have been assigned storage locations. The algorithm takes into account the special characteristics of products by ensuring that all flammable products are stored in the fire-safe zone and all high-value products are stored securely. It outputs a list of the bins each product is assigned to, as well as a list of the unpacked products and unpacked bins. The 3 models were evaluated using the algorithm outputs. This comparison was based on technical and performance criteria and performed using data simulation in Excel. The technical criteria assess whether the models meet the minimum solution requirements. The chosen model must pack all non-obsolete products and achieve the targeted percentage of high-level picks. The technical comparison revealed the following results. As shown, Model 3 does not pack all the non-obsolete products and thus could not be selected as the solution. Models 1 and 2 satisfy all technical criteria and were compared based on performance. The performance criteria measure the effectiveness of the models at reducing warehouse overcapacity and increasing the number of bins available and transactions picked. Model 1 reduces warehouse overcapacity by 18% more than Model 2. In addition, Model 1 resulted in 4,825 more available bins and 7 more daily transactions. Therefore, Model 1 performed the best and was selected as the solution. Model 1 was then validated to determine if the solution in fact shortens order picking time, thereby increasing throughput. The validation was performed using simulation modeling in Flexum. 2 models were built, the first depicting the current storage policy and the second the suggested solution. Both models simulated the previous year's order picking transactions to replicate real-life warehouse implementation. The results revealed that the solution shortens order picking time by 3 hours and 20 minutes per day. This translates to 32.4 seconds saved per pick. In addition, the waiting time for a forklift was reduced by 3 minutes and 17 seconds per product. In conclusion, the results of the data simulation and validation prove that the storage assignment algorithm improves the order picking process, increases warehouse throughput, and enhances operational efficiency, and thus solves Agricorp SA's storage location assignment problem. The algorithm has widespread application and is not limited to distribution warehouses. It can be used to improve efficiency in production and cross-docking warehouses, grocery and clothing stores, libraries, parking lots, or any storage-related system. So, After all this searching, I found the key to an efficient order picking process. Optimal storage location. Thank you.
Well done, Sarah, on such excellent results. The company now has the key to operate within its capacity. Our next presenter will be telling us about using explosive AI to reduce the uncertainty of cash flow prediction. Please put your hands together for Caitlin Talek.
So this is me at age 3. I want to be a pop star or a vet. I'm not really sure what an engineer is yet, and something is about to change in the way I think about the world that is going to annoy my parents almost to their despair for the next 2 decades of my life. I'm 3 years old, and I start to ask, why? Why is grandma's hair grey? Why are adults so tired all of the time? Why can't I eat cake for dinner? Why does the world work like this? How do we answer the questions that 3-year-olds have about the world? How do I answer the questions that I have about the world? How do we answer the questions that businesses have? When I was 3 years old and wondered why my grandmother's hair was grey, one of my 2 incredibly patient parents sat me down and helped me to see a correlation. Grandma is old. There are other old people in the world. Grandma has grey hair. There are other people in the world with grey hair too. By observing these 2 samples of people that share common traits with my grandmother, I might be able to begin to extrapolate what could be universally true about the world. I looked at other old people. I looked at other people with grey hair. Unsurprisingly, I found an overlap. Lots of old people have grey hair. My grandmother was not some strange grey-haired exception to our otherwise brown-haired household. She's just old. As all children do, I would spend the rest of my childhood asking why, and then looking at data in the real world, searching for strong correlations to understand as best as I can why the world is the way it is. Today, 2 things have changed. 1, big data. Far from having to rely on the small sample of graying heads in my immediate community, I now have access to thousands upon thousands of databases. We have enough data to answer as many questions as any one 3-year-old could have. 2, in spite of this, myself and my peers have stopped asking why. But imagine the explosive potential of massive data sets and state-of-the-art artificial intelligence in answering this very question. This is explainable artificial intelligence. It's the algorithm that every scientist and every 3-year-old dreams of. It's the algorithm I use for my final year project too. When Kuro, a private school management company, approached me at the beginning of the year, it had one question. How will our customers behave this month? That is, in any given month, which of our customers will maintain, which of our customers will cure outstanding debt, and which of our customers will default? In the age of artificial intelligence, this is a simple question to answer. It's the equivalent of telling a 3-year-old child yes or no. But any good 3-year-old and any good scientist is likely to have another question. Why? Explainable artificial intelligence is the answer to impenetrable black box algorithms. It's the answer to a number of questions that scientists, engineers, and businesses may have about their own algorithms and how they make decisions. First, let's understand what explainability means in this context. An XAI model can be explainable in any of 4 ways. Explanation of the model itself, explanation of reasoning, explanation of evidence, and explanation of model decisions. While these are all valuable, let's focus on explanation of reasoning and explanation of evidence to answer the question of why. Explanation of reasoning asks, given that grandma is old, how likely is it that she has grey hair? Or generally, how the evidence comes to affect the model's conclusion. Explanation of evidence asks, what is the most probable reason for grandma's grey hair? Or generally, what is the most probable configuration of evidence given the model's known conclusion? To better understand these tools, let's look at how they might be applied. There are 2 primary XAI approaches: post hoc explainability and transparent models. Post hoc explainability entails applying explanation techniques to existing, not necessarily XAI models. Transparent models, or inherently explainable models, are those models which are explainable by their very nature, either because their formulation is quite easy to follow, like a linear regression model, or because they are inherently revealing of how they make decisions. Think Bayesian networks. This is the Bayesian network I built Kuro to help them predict customer payment behavior. Let's do a quick orientation. These are the features relating to the customer profile, things like age, region, credit score, and other relevant personal information. Here are the previous payment behaviors of the customer, things like balance, payment amounts, and behavior outcome. This node over here is what this model was structured to predict from the features I've just introduced. This month's payment behavior outcome: cure, maintain, or default. Now, I can think of a few good why questions you might have. Let's start with, why does the model look like that? One of the cool things about Bayesian networks is that they can learn this kind of structure directly from the data. To begin with, the Bayesian network learns about the world in much the same way I did as a 3-year-old. It looks for strong correlations. In the same way that I reasoned that because lots of old people have grey hair, maybe there's some kind of connection between being old and having grey hair, a Bayesian network looks at the strength of the relationships between one feature state and another, like how school location seems to be strongly correlated to school brand. This is because in the real world, the distribution of different Kuro schools is different in each province. The model has noticed, for example, that a Kuro academy is much more likely to be located in Gauteng than in Limpopo. The arrow between the two variables indicates the prevalence of a relationship. In this way, the model is actually quite revealing of how it makes decisions. If you tell the model that you are a resident of Gauteng, the probability that you are a customer of Kuro Academy goes up. If you tell the model that your oldest child is 3 years old, the probability that you're a customer of Kuro Castle, Kuro's nursery school offering, goes up. This is actually a demonstration of explanation of reasoning, one of the explanation techniques we mentioned earlier. We can see how the evidence presented affects the model's prediction. If you were to ask the model, why did you predict that this customer goes to a Kuro Castle school, it would answer, because their child is only 3 years old. But how well does this kind of prediction work? Specifically, how does it compare to traditional AI approaches? The model achieves an average prediction accuracy of 83%. This is comparable to the performance of a linear regression model trained on the same data and used in a similar application context, which achieves an accuracy of 85%. The model's best prediction accuracy is 96%. Specifically, the model is able to predict the default behavior with a 96% accuracy. This is better than even state-of-the-art neural networks, which achieve about a 93% accuracy. Even more impactful than this kind of prediction, though, is the explanation that we mentioned earlier: explanation of reasoning and explanation of evidence. Remember that explanation of evidence is concerned with the most probable explanation for grandma's grey hair. For this, we might tell the model that a particular customer has defaulted on their last 3 payments and ask it to explain why it thinks this is the case. The model identifies 2 types of payers: Peter and John. Peter and John have both defaulted on their last 3 payments. The only other known difference between them is that Peter is a customer of Kuro Academy and John is a customer of Kuro Meridian, which is Kuro's budget school offering that is often located in more impoverished areas. When we ask the model to offer the most probable explanation for why these 2 payers have defaulted, it tells us this: Peter has 4 children, some outstanding debt, and a low-risk credit score. John has 1 child, about the same outstanding debt as Peter, and a high-risk credit score. What this explanation tells us is though the poor payment behavior in the Kuro Academy customer is likely due to some other extreme, like having 4 children, this type of payment is observed in even a much more typical Meridian customer payer. This is likely due to the fact that these customers are just less reliable, as is reflected in the higher risk credit score. Importantly, these 2 customers would have exactly the same prediction output. It is only by asking why that we can understand these 2 customers as belonging to 2 very distinct circumstances. Importantly, Kuro is able to develop a much deeper understanding of its customer base, one that would allow its debt collection department to go as far as developing customized relief and recovery plans for defaulting customers. Explainable artificial intelligence gives Kuro, or any other company, so much more than the power of mere prediction. Which brings me to my last why. Why does this matter? It matters because if businesses do not understand their customers' behavior, they cannot change it. It matters because if we are going to allow robots to make decisions about people's lives, they need to be able to explain that those decisions are fair and unprejudiced. It matters because we can do so much better. Using the same data we would otherwise use to make mere predictions, we can derive meaningful insights and explanation. It matters because inside each of us is a 3-year-old who longs to know why.
We can all relate to that 3-year-old who always has that why question. Well done, Caitlin, on a well-executed prediction model. And that was our final presenter for this evening. Well done again to all our finalists. As you can see, the competition is very high this year. So I wish you all the best for the rest of this evening. But before we continue, I'd like to make some few announcements. We would like to appreciate all the project sponsors who gave input to this year's final year projects. Your input is visible from the high complexity that we found in this year's final year projects. We would like to welcome our future sponsors for 2022 to please go to the website where you will find guidance on how to sponsor a project. After the winners have been announced, we invite you to please use the webinar portal to enter some of the virtual rooms. In these virtual rooms, you will be able to interact with some of our sponsors. We will now enter into the third segment of our program, which is the award ceremony. Please help me welcome the head of department, Professor Sarma Yadavali, who will lead us in this section.
Good evening, ladies and gentlemen. It is a customary to acknowledge a few people before we announce the winners. First of all, let me congratulate all the selected students who made their presentations today. Please allow me to extend our profound appreciation once again to our development partners and sponsors, donors in this great event for their eagerness and enthusiasm in coming to our assistance. Ladies and gentlemen, I am proud of my colleagues who were also the project leaders and for their effort in helping the students in the projects throughout the year, particularly in these difficult times of COVID. Also, thanks to all the colleagues who have assisted in various roles for this project evening. Well done, colleagues. Thank you. I wish to say thank you to all our external examiners for examining these projects. Thanks to our adjudicators who have adjudicated the project presentations today. Thank you all once again. Thanks are due to Prof. Marnai DeFries, the project coordinator in the department, who managed the entire year extremely well. Thank you once again, Marnai. Special thanks go to Honley and Bonolo, our departmental administrators, for all their effort in the arrangements of today's function. Last but not least, I wish to thank Johnny and his team for multimedia for their professional service in realizing today's webinar. Now comes to the announcement of the winners. There are 3 categories of prizes we announce. The first category is the poster presentation. The second is the project document, and then the project presentations. Best posters. Second runner-up, Mohammad Jaffa. First runner-up, Carmen Petersa. And the winner is Emma Fitzsimmons. Best document. Second runner-up, Juliana Skeepers. First runner-up, Omar Swart. And the winner, Sarah McInerney. Best presentations. Second runner-up, Mohammad Jaffa. First runner-up, Caitlin Talak. And the winner, Sarah McInerney. Thank you for joining this event. Virtual discussion rooms are now open. Good evening. Stay safe.